Sorry, guys. So yeah, I'm really happy to be here. We'll be talking about COM and DCOM, which is quite a trendy subject these days among the Active Directory and Windows world. So to begin with, if you want just to get the slide deck, you can just take a picture or get it from there instead of having to take pictures on the slides you find interesting. So I'm just going to leave it for a few seconds. Okay. Thanks. So yeah, just a quick introduction. I'm Julien. I'm French. Sorry, nobody's perfect here. I work as a pen tester, red teamer at Orange Cyber Defense, so quite the classic offensive security type of guy. But still, I'm trying to get interested more and more in the blue team side, detection engineering and IOCs and so on. We'll see during this talk. We'll be talking a bit about that too. So yeah, I've done some research already on various topics. But today we're celebrating a birthday, actually. The birthday of COM and DCOM. Well, it's not exactly the 30th birthday because it's the 29th, but I had to find a cool title, so 1 year off doesn't really matter. And so, why are we talking about that age? Why are we talking about this birthday? Not because the protocol is obsolete now, but because it's so deep in the operating system that we find it basically everywhere. And so obviously we still have plenty of new security issues regarding this COM and DCOM duo. So these, for example, are articles from 2024 and 2025. And you can see that there are many of them for a 30 years old protocol, or let's say mechanism. And so yeah, basically what we are going to do today is to try to demystify a bit this mechanism, try and see how they fit in the cyber kill chain. And the idea here would be mostly a beginner level introduction to COM and DCOM. So if you're an expert, I'm not sure we'll learn that much, but I hope you still have one thing or two to learn. And really, yes, the idea would be to give you the basic knowledge to better understand all these articles I showed you just before. And so this is a component object model across the kill chain. And as you can see, it's in many, many stages. Well, we'll be talking about most of them, but just regarding privilege escalation, we won't have much time to cover this because it's probably a 2 or 3 hour talk, and it have been already been presented a lot this year. So I just leave the references at the end of the slides, and hopefully with the knowledge we'll get today, you'll have enough ideas of how things works to better understand all these articles that are linked at the end. So yeah, after this quick introduction, let's really dive into component object model to better understand how it works. But Microsoft documentation and definitions are quite blurry. I was not really able to understand how COM works from there. So let's present a short story of a C++ program which wants to talk with the Windows firewall. And he's asking, so how can I list these firewall rules that you have? And it's easy. Everything is through a COM interface. So let's try and see a bit what a COM interface looks like. So you have some parameters here. And to start with, we have this CLS ID, which is a unique identifier for the COM object. And you have this prog ID too, which is kind of a friendly name, let's say, for programmers to better manipulate instead of always having to type the CLS ID. And you can also see this so-called COM server, which is, in this case, a DLL, which has to be loaded, and it implements all the functions that we want to use in our program. So we will have to load this library to use the interfaces. So here are the interfaces. We have 3 of them. The first and the last one, they are by default on every COM object, so we'll mainly focus on the second one. And because it's an interface, you can see that it has methods and that can be called, properties that can be get or set eventually. And in this simple case study, we just try and use this firewall enabled. So it's just a boolean telling if the firewall is enabled or not on Windows. So to go on with our story, we also can ask a question if the C++ program wants to list any other interfaces available, he may want other features from the operating system. So where all of this is stored in Windows. So like everything else in Windows, it's in a registry key. And so you can see we have this CLS ID, which is associated with the COM object. And you also retrieve any parameters like this DLL that should be loaded. And just like that, you can eventually list every interfaces made available to programs in Windows. So from now, we can just try and implement that in C++. So here is a short program. We won't go right into every detail, but just to give you an overview, we can see this prog ID, the friendly name. We're using it to get the CLS ID, because as programmers, we do not know CLS ID by heart. So we just use this prog ID, retrieve the CLS ID. And from the CLS ID, we're able to create an instance of the object. And then from this instance, we can just get the parameter, the firewall enabled. And eventually we will just display if yes or no, the firewall is enabled. So we have our short program here, and we just run it, and it tells you, oh, the firewall is disabled, you're too bad. And eventually, the firewall was disabled. So it works pretty well like this. And so if we look a bit more into the details, what happens under the hood, we see that the DLL is indeed loaded by our program. And how does he know how to load the DLL? Well, as we said earlier, he just have to look in the registry. And so we had our prog ID. So from the prog ID, he will look for the CLS ID. All of this is registered in the registry. And then once you have the CLS ID, we just are able to retrieve the DLL, and the DLL is loaded by our program. So this is basically how things work for component object model. And what's interesting and powerful too is that if VBScript, for example, wants to use this COM object, it's as easy as for the C++ program, because the interface is actually usable by any program. It's what James Forshaw, who worked a lot on COM, called this interoperability heaven. So basically, it unifies the way objects exposes feeders one to the other. So that's quite powerful and useful, and maybe why it's so deep in the operating system, actually. So now that we know a bit more about how it works, let's see how attackers use it across the kill chain, starting with initial access. So what I mean by initial access is just you're able to make a user double-click on the payload, no matter really the file for now. For example, through a mail phishing, let's say. And so when we look at this prog ID on the left, so this is a list of prog ID and the features we are able to implement in programs. We can see that we can do basically anything we want as an attacker, like command execution, file download, or set up a new scheduled task, and so on. So really powerful for attackers to use these prog IDs in an initial access scenario, especially considering that we can use any type of scripting engine. So there's really a lot of payloads available for attackers to use, and they can rely on COM to, for example, run commands. So this is a quick example. We can see a Windows shortcut, which was renamed totallylegit.pdf. And under the hood, what he does is that he launches mshta.exe, which itself is able to launch some VBScript. And eventually we pop a calc when we double click on this file. So this is a bit to illustrate how any kind of payload really can be used with component object model. But actually, apart from this few prog ID that I showed, you have 30,000 interfaces. So you have a wide range of choices for an attacker to pick from to try and get command execution and so on. So in a detection engineering, you cannot just rely on these few prog IDs. You may have hidden interfaces. Not all of them are documented. So this is a great blog post by Mendiant, which shows basically how they reverse engineered some undocumented COM objects to find activable command execution and so on in them. But they're probably still among the 30,000 a lot which could be used to get command execution here. So yeah, this was basically how we could use it in the initial access part. But now that we have code execution on the machine, obviously we want it to survive, for example, reboots, or otherwise all our efforts at phishing would be long gone. So COM can also be used for persistence. So the idea here is to rely on the way DLLs are loaded. You may already have heard this COM hijack definition, but so this is what I showed earlier about how the registry were able to, the program was able to parse the registry and find the DLL. But under the hood, it's a bit more complex than that. We actually have a few more lines. These lines are the name not found. And what's different with the lines just after is this HKCU. HCU means current user, so it's because in Windows, when programs look for a registry key, most of the time they will first look in the current user configuration, and if nothing is defined there, it will fall back to the global configuration. So that's why here the CLS ID was not written in the current user configuration, so it just falls back to the global configuration. And what's interesting here is that this one is writable by the attacker, because if he gets command execution as the user, he's able to edit this value. And by editing this value, there is no fallback after that. It's just the value that will be taken by the program. So eventually we can point it to another DLL. So basically a backdoor. So that's what we're going to do now. So this is HKCU. We can see current user here. This is through the graphical interface just because it's a bit easier for us to comprehend, to understand, but obviously all of this will be done through command line or hidden to the user. So here what we've done is that we added a new CLS ID, and it points to the backdoor, so to firewall API, but located at a backdoor folder that we created. Obviously, we have to put the backdoor here first. But then, when we run the program that we had previously done, instead of having his usual behavior, now it executes the backdoor. So it can be used as a way to persist. And so what we can see here is that instead of the name not found, now it finds something in HKCU. So it's able to fall back, and to not fall back to the default configuration and run the backdoor. And so this is interesting, of course, but no user in real life will use my firewall check program. So we have to target existing programs in the real life. And so here are a few characteristics, let's say, that can be useful to target programs to do this COM hijack and persistence. So ideally, the program should run regularly, for example, every time a user restarts the computer, the program is run. Ideally, it should be open the whole session so that the attacker doesn't lose the command and control access during the operation, during the day. And also, ideally, it should communicate with internet. Otherwise, from a detection point of view, it's pretty obvious that, for example, a calculator should not be talking to the internet. Well, we never know with Windows, but so here are a few examples of programs which are perfect targets, and that we actually, during our red team engagements, use a lot. So you have all this Office suite program like OneDrive. Obviously, it will be run all the time in background, and it will communicate with internet. So, and really nice for us. The browsers are a good target too, like Google Chrome, for example. VPN clients, EDRs, ironically, are also good targets for this kind of attack. So this was the basic COM hijack, but in the last years, we also saw like advanced COM hijack, and all of them rely kind of on the same idea of having this name not found and a fallback. That it's basically what was presented a few talks before, with the treat as I believe that we can see on the middle of the screen. So basically, almost any name not found in HKCO can eventually rely on persistence and code execution. We won't go into details, but you have the links right here if you're interested. And you don't even have to stop at the registry to set up a persistence using component object model. Here we can see in some scheduled tasks, we also have this CLSID that appears that can be hijacked too. So now that we've been able to get code execution on a machine, to set up some persistence, we'll see how we could move from one machine to the other, and once again, using component object model. So the scenario basically is that you have code execution from one Windows machine to another, one machine to a Windows machine, and we assume that you have administrator rights. So it's basically how lateral movement is considered actually. Sorry. Maybe better like this. So how can we use a remote COM object? It's actually called DCOM. It's an extension of COM, which appeared like a few years after. And it's basically transparent, and it relies on the TCP port 135, using the famous now RPC protocol. And DCOM has many characteristics. We'll focus on this one, which is the app ID. And app ID is basically an identifier for a group of COM classes. And when it exists, it means that this object is can be called remotely using DCOM. So we are only looking now at COM objects which have an app ID. And basically, this app ID defines a group, and this group has a set of configuration, for example, if they can be activated remotely or not, and so on. So if we look at the COM class that we had for our firewall check example, we can see that it has an app ID actually, so we can use it remotely. And it's what I've done. I'm not showing you the code, but we can just create a small program to test if the firewall is enabled on a remote machine. And in fact, it works. It can tell you if the firewall is enabled on the remote machine or not. And it's using DCOM under the hood. But unfortunately for attackers, not every class has an app ID. So this was basically the class able to run commands that we saw earlier in the initial access part. It has no app ID, so it cannot be called remotely. So we cannot use it to create lateral movement. So we'll try to find the appropriate class which has an app ID. We'll maybe find for some methods with interesting keywords, like exec could be an interesting keyword. And let's hope we find one which enables lateral movement. So I have this small program which just passes the registry, and it finds every single class which has an app ID, so it will be able to communicate through DCOM, and which has the exec. So here we have exec WB, why not? But this one is way more interesting. We have execute shell command. So MMC20, what we're going to do is we are going basically to instantiate this remote COM object and just run this method and hope that we have command execution. So it's being initialized here with PowerShell. It's maybe a bit too small for you to see, but basically what we have is the CLSID and the server name. We want to run the command on, and then a few parameters to the method. Basically, we're telling him to launch like calc.exe. And if we do that, we can see that the calculator is indeed spawned on the remote machine. So it works. You just have to be careful here why it works. It's because first we are administrator of the remote machine. This was a huge prerequisite. And we also had to access the port 135. So here, in that case, the firewall was disabled. But from my experience, it's the case most of the time we can reach like SMB port and RPC port in an internal pen test. So it's acceptable, let's say, for lateral movement requirement. And what we've done here is that we accidentally found DCOM exec. Maybe you've heard of it. It's a well-known lateral movement script in Python, relying on the impacket library. So, and it's basically, it uses the MMC20 COM object to do its lateral movement. But you can go way further. We could look for other keywords. We could look for undocumented, just like we talked about a few slides before. So like do reverse engineering on component object models objects. And there is not only like shell execute, we could also look for a COM object able to run Office macros, for example, and from there get command execution and so on. So this was done like extensively by the community research the offensive research community, and we have lots of references on that, like maybe dozens of articles which show more and more complicated way to get command execution using DCOM. So now that we are able to run commands on another computer, one thing that we could like to do, that you would like to do, is maybe impersonate a user. So here we just look on a remote server and we can see that our domain admin, like the crown jewels, the one we want to target, is connected using RDP. So the good old school way to do that was like to connect and to dump maybe LSAS and so on, but it's not really, we're not really able to do that anymore due to like heavy detection on these techniques. So we'll see how COM and DCOM could be used in an impersonation scenario. And this is maybe a bit less known than the lateral movement scenario. And so if we look back at the COM object properties in the app ID, we can see that it has a run as property. And here it points to the interactive user. So what it means is that if we're able to instantiate this DCOM object on a remote computer, it will run in the session of a connected user. So in that case, we would like to run as the domain administrator. So what we're going to do is look for, so yeah, what I meant here is that we could do the COM hijack that we did earlier with the registry key and so on. We could do it also remotely because we have a remote service to interact with the Windows registry, and we also have a remote service, SMB, which let us basically put files on disk. So we could set up a COM hijack, but not locally this time, but remotely. And this time we're not limited to HKCU because we're administrators, so we can even like edit the fallback keys. Well, they are not fallbacking anymore, but we can edit any key basically and make it vulnerable to COM hijack. So what we are still going to do is that we are going to look for COM objects once again, which can be launched remotely, so they have an app ID. They will run as the interactive user. This, once again, is in the registry, and eventually, which exists on the targeted Windows version. What I have not told so far is that the interfaces available from one Windows to another are quite like different. So we really have to like do this work for every single Windows version we are targeting. And so we have this great project which is called Comtanasia, which let us enumerate pretty easily the component object models on a specific Windows. You just have to run it, and it will generate like a CSV file, a huge CSV file that you can parse to get the exact parameters you want. So in this case, an app ID, the running as interactive user, and so on. And so we eventually find the perfect candidate. It has an app ID, it runs as the interactive user. So let's try to instantiate it remotely, targeting the session of the domain admin. So we have this small program I've made, but basically I really got inspired by these references. And so we will target a specific server, and we'll target a specific session. And what it does is it targets under the hood the CLS ID we just saw earlier, and it will copy our malicious DLL, the equivalent of the backdoor DLL we had for local COM hijack, but this time we'll do it remotely, and we'll be able to edit also the registry to let's create the backdoor key, and after a few like steps we have to do on the registry, we're able to point this CLS ID to our malicious DLL. And eventually, when we create the remote instance, we're just able to get command execution, and then we clean the registry. And if we look in the remote machine, we can see that we eventually have this calculator, but this time running as the domain admin. So we are basically able to create a backdoor running as domain admin, and then do whatever we want, set up a domain persistence, or maybe all sorts of things. And a quick note too, so I was talking about remote COM hijack. You can also do remote COM DLL hijack. This is a well-known technique, DLL hijack, but done through COM remotely, not so well-known. There was already a talk on that, so I'm just giving a reference to the GitHub project, which explained pretty well how it works for those interested in this new lateral movement plus impersonation techniques. And basically, we're using that a lot during our red team engagements at this time. So some defensive measures, of course, regarding all this COM lateral movement, impersonation, persistence. So here's a few of them. Most of them will rely on detecting like unusual registry editions, because of course you're not so supposed to edit like HKCU or basically this kind of registry keys at all. Especially from like a normal user workstation and so on. You will also have a strong focus on DLLs, so unsigned DLLs, but it's quite hard to detect because even Windows have DLLs that are not signed at the moment, so it's a bit hard to get, but maybe one day we'll get there. DLLs loaded outside of program files and System32, of course. Known abuse CLS ID, it's still an ID, but as I said, we may have undocumented ones which may be used by threat actors, so it's quite hard, but still building a list of CLS ID. I may actually do that in the upcoming months. Building a list of all well-known CLS ID could be a detection ID. And the usual uncommon network interactions for this lateral movement. Why would this workstation talk to the server and try to run COM objects on it? So you have like sensors like maybe Varonis or Darktrace products, which could be used to like get this uncommon network interactions. You also have research recently on RPC firewalls. So basically, it's firewalling at the COM level, at the RPC level, to allow or not allow this kind of stuff. I'm leaving you the links if you're interested. And eventually, what I found to be the best prevention step would be to harden your architecture. So basically, the good old network segmentation principle of least privilege, why this workstation would have access to RPC port on a server. Maybe it should not. So here it's just like the French guides of the cybersecurity agency, but I guess every country has its own, so you can just adapt the recommendation. So yeah, that was basically it regarding this quite little introduction to COM and DCOM. Here is a takeaway that I like. So we have a 30 years old mechanism, and we still have new things to look for as security researchers. As we can see this year, there were plenty of research on the subject. But security measures from 30 years ago, like least privilege and so on, are still relevant. So we have some hope in this world. And here is a list of stuff that we did not have time for, but all related to COM and DCOM that I highly recommend you to look for, like especially the privilege escalation is quite interesting. So you have like lots of references, like maybe I have 10 pages of them at the end for you to like just pick what you find interesting, the subject you like, and try to go a bit deeper in these blog posts. And some encouragements. Of course, my company, Orange Cyber Defense, it gives me like some time, some days here and there to work on this kind of subject and then show it to others. So I really thank them. And so as Claire and Jean-Pascal, which are the reference of research and development at Orange. And of course, this awesome conference that I've been pleased to be at, HackLU. So thank you so much.